Our problem is from GATE 2020 mathematics paper, question number 45. The problem given is, suppose that f of z, the given polynomial, has product n equal to 1 to 17, z minus pi divided by n, where z is a complex number, and gamma of t is the curve given as gamma of t equal to e to the power of 2it, where t belongs to the closed interval 0, 2 pi. If integration over gamma f dash of z divided by f of z dz equal to given alpha pi I, then the value of alpha is equal to, so it is given the integration of f dash of z divided by f of z dz in terms of alpha pi I. So now we have to calculate the value of alpha. So now to solve this problem, the NPTEL reference is given by module 1 lecture number 2. The title of this lecture is lecture number 2 of advanced complex analysis part 1 topics. So the title of this lecture is the argument principle, Roche's theorem and the fundamental theorem of algebra by Dr. T.E. Venkata. He is from Department of Mathematics, IIT Madras. Even you can watch this lecture using this YouTube link. So now coming to the solution. So given f of z as product n equal to 1 to 17 z minus pi divided by n. So by expanding this product, we get the function f of z as z minus pi, z minus pi by 2, z minus pi by 3, and so on, z minus pi by 17 up to 17. So all these factors together with the multiplication of this factor is nothing but the given polynomial f of z, and given gamma of p is e to the power of 2it, where t belongs to the closed interval 0, 2 pi. So now we have to calculate integration over gamma f dash of z divided by f of z is equal to question mark. So firstly, let me explain the curve gamma, how it looks like. So by taking the complex plane as this, and this is the point 1, this is the point -1 approximately, I, and approximately this is minus I. So now what the curve gamma of t is given as, so when we take the point t is equal to 0, we get gamma of 0 as 1. That means the curve starts here. So let me highlight that point, this point at the point 1. So when we move towards 2 pi, the value of t, that means let me take the value of t as pi divided by 2. That means at that point t equal to pi by 2, we get the value of gamma of pi by 2 as e to the power of pi I, that is minus, it is minus 1. That is, so let me write gamma of 0 equal to 1 and gamma of pi by 2 equal to minus 1. That means this point. But the question here is, does this curve travels, or one can see simply that gamma of t is a circle, since its absolute value is 1, and so that means that it is a circle of radius 1 and it travels from the point 1. But the question here is, does it travels in the clockwise direction or anti-clockwise direction? So for that, what we need is, we can simply check by taking another point in between 0 and pi by 2. Or so let me take a point gamma of pi by 4. You can check its value is gamma of pi by 4 is I. That means this point. So that means we are getting gamma of 0 equal to 1 and gamma of pi by 4 equal to gamma of pi by 2 equal to gamma of pi by 4 equal to I and gamma of pi by 2 equal to -1. That means the curve gamma travels in this direction up to the point pi by 2. And whereas coming when we move the point t more towards 2 pi, we get gamma of pi equal to 0 again. So the curve travels. If you take another point 3 pi by 2, we get minus I. And when we keep moving towards 2 pi, we get gamma of pi equal to 0 and gamma of next point or gamma of 2 pi equal to 0 again. That means the curve gamma of t is nothing but this circle in this direction, anti-clockwise direction. But the point here is how many times this curve gamma on this circle travels. So when we look at the points, gamma of 0 equal to 1, that means the curve starts here, and gamma of pi by t equal to -1, that means the curve traveled in this direction. And when the point at the point t equal to pi, the curve is gamma of, sorry, these two values are ones. So 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 when the value of t is pi, it is 1. So that means by the time you move the points t from 0 to pi, you are moving the curves gamma along this circle one time. When you move the points from points t from 0 to pi, but whereas you move the points from pi to 2 pi again, the curve gamma travels again on this circle another once more. That means in total, when you move the point t from 0 to 2 pi, the curve gamma of t travels along this circle twice. With the circle is radius of radius 1. So that is for t belongs to 0 comma 2 pi, the curve gamma of t moves or travels along the circle mod z equal to 1 twice. So why I am saying is, to solve this problem we use argument principle. So when we look at the argument principle, we have by argument principle we have 1 divided by 2 pi I times integration over gamma f dash of z divided by f of z dz equal to nothing but n minus p, where n equal to the number of zeros of f of z inside gamma, and p is the number of poles of f of z inside gamma. Of course, this should be counted with multiplicities. Multiplicities. So the point here, the the term counted with multiplicity is important in this problem. So since the curve gamma travels twice along this circle, so the number of zeros or poles should be counted twice since the curve travels twice. So that is, so we get 1 divided by 2 pi I times integration gamma over, sorry, integration gamma of f dash of z divided by f of z dz equal to n minus p, as we defined the terms n and p. How n is the number of zeros of f of z, where f of z is our given function, the polynomial, inside gamma, inside gamma or gamma of p. Okay, let me write gamma only. And p is the number of poles of f of z inside gamma counted with multiplicities. So now looking at the function f of z, f of z is nothing but z minus pi, z minus pi by 2, z minus pi by 3, z minus pi by 4 up to z minus pi by 17. So, so the zeros of f of z are nothing but the points pi, comma pi by 2, comma pi by 3 up to pi by 17. And since it is a polynomial of degree 17, which can be seen easily since there are 17 factors, so it is a polynomial of degree 17. So, and since it is a polynomial, so that means it is an entire function, so it does not have any singularities, and the zeros of f of z are these points, and it is entire. So it does not have any poles in C, the complex plane. So, but the question here is, out of all these zeros from pi to pi, pi by 2, pi by 3 to pi by 17, how many points does lie inside the closed curve gamma? So for that, we can see since the just simply the radius of that curve gamma. Since we can see gamma is a curve of radius 1, since its absolute value is 1, that represents the radius of this circle gamma. So, so out of these points, so out of these points, pi, pi by 2, pi by 3 up to pi by 17, we have pi value is approximately 3.141 when we take rounded up to 3 figures approximately. So pi by 2 is approximately 1.56 approximately, and pi by 3 is 1.0, 1.04. This is approximately. And up to 5 by 17 is 0.184 approximately. So what does this means is, so out of all those zeros, the points lies in this way. Yes. So since it is 1, so let me take this 2, 3. So okay, let me reduce it. Let me take this point as 2, this point as 3. So then the point 5 lies approximately here, and the point 5 by 2 lies approximately 1.57. That means approximately here, and pi by 3 is approximately here, and of course all these 3 points lies outside this circle margin equal to 1. Then coming to the point pi by 4, it lies inside the circle margin equal to 1. So let me take this point as pi by 4, and continuing we get approximately the point pi by 17 as this point. So we can see out of all these 17 points, the only points lies inside this closure curve gamma is from pi by 4 to pi by 17, and those are in 14 number. So out of these zeros of f of z, the only points lies inside gamma are pi by 4, pi by 5 to pi by 17. And these are 14. So in total we get 1 divided by 2 pi I times integration over gamma f dash of z divided by f of z dz equal to 2 times 14 minus 0. Here, since the curve gamma travels twice along that circle, margin equal to 1. So I'm just multiplying the number of zeros with 2. So in total we get this as 28. But it is asked to calculate the value of integration over gamma f dash of z divided by f of z dz equal to 56 times pi I. So this is given as alpha pi I. So the value of alpha is nothing but 56. In this problem, one may get confused. One can solve through this argument principle, but one can get confused with the number of poles that we have to count inside this closed curve gamma. Since the curve gamma travels twice along this circle, so we have to count the number of zeros twice. Since in the restricted theorem, the argument principle tells us the number of zeros inside gamma counted with multiplicities, that is 2 times the total number of zeros inside gamma. So hence the answer is 56. Thank you.